In this video, we're going to find the second derivative of an implicitly defined equation. So we will call that y double prime. Or if we were using the dy dx notation, or the equivalent to that, we would call it d squared y over dx squared. In my work, I'll be calling it y double prime just to make it easier to write. And we all know that the second derivative requires we know the first derivative. And so we will start with finding the first derivative. Or if you want to just pause the video and work that out yourself first, instead of watching me do it, I encourage you to pause the video and try that one yourself right now. And I'm going to go ahead and work that out now. So the derivative of the equation x squared minus y squared equals 10. We apply the derivative to both sides. The derivative of 10 is, since that's a constant, the derivative will be 0. On the left side, the derivative of x squared with respect to x is, using the power rule, 2x. And because this is an implicitly defined equation and y is implicitly the function f of x, we think of this as f of x squared, and that derivative is going to require the chain rule. So it'll be 2y times y prime. So remember, we think of that as the power rule. And so like if you think of y squared as really f of x squared, it's now clearly a function inside of another function. That's why we had the chain rule here. So solving for y prime, I would do that by subtracting 2x to the other side and getting negative 2x. And then I would divide by negative 2y. And so y prime, it would just simply be x over y, simplifying out all the 2's. Okay, so I'm just going to circle that. It's not my final answer, but I might have to come back to that. And now the second derivative is always the derivative of the first derivative. So on this side, I'm going to be finding the derivative of the equation y prime equals x over y. So on the left side, it's like saying what's the derivative of f prime? That would be f double prime. So this left side is simply second derivative. But now on the right, this is a quotient. It's x divided by our function of x. So for this side, we're going to use the quotient rule and go low d high, y times the derivative of x, 1, minus high, derivative of the low, y prime, over the square of what's below, so all over y squared. And technically we're done with the calculus part. However, we don't want to leave y prime in our answer. We want to leave this entire right side strictly in terms of x and y, because ultimately I want to be able to just insert that. If I wanted to know the numerical value of this, I would have to know I want to know just the x and the y. And so let's take a minute here and notice that I worked out y prime earlier, so I have something I can substitute for that. So it'll be y minus x times the fraction x over y all over y squared. And let's take a minute now to simplify the expression. I've got y minus, now if you look here, you have to be careful with the fractions here. It's x over 1 times x over y. This is going to be x squared over y, and then that's all over y squared. So now I'd like to kill the complex fraction by multiplying everything by another y over y. And I'll just move this over so I have a little more room. And let's multiply out. So I have y squared minus, and over here we can cancel the y's, so it'll be x squared over y cubed. It'd be perfectly fine to leave this as your answer. Y double prime equals y squared minus x squared over y cubed. If you want to for a minute, I encourage you to pause the video at this point, look at our answer, and see if you notice any other things we could do to simplify this in a different way. There's a really neat thing we can do here with this. Take a minute and observe all the equations we've used in this problem and see if anything pops out that you could do to simplify this. I'll explain in a minute what I think I would do. So maybe you noticed that in the original equation it was told to us that x squared minus y squared equals 10. But in my derivative, my second derivative, I have y squared minus x squared, which is very, very similar, but just the opposite of the given expression, x squared minus y squared. In fact, if I just multiplied both sides of the given equation by minus 1, it would produce positive y squared minus x squared equals negative 10. And so if you wanted to do one last bit of simplifying of this second derivative, you could replace all of this numerator with just simply a minus 10. And this could be your second derivative. Not that there's anything wrong with this. So if you're working in my math lab or whatever, I think either answer is fine. This is a neat way to simplify it quite a bit more, but just want to point that out. So for e-learning this weekend or this Monday, please use these two videos and complete the remainder of assignment 3.8.